Have you ever stopped to think about what really happens when you hit run on a Python script? You write this clean, simple code, but underneath it all, there's this secret language working behind the scenes, a hidden set of instructions that the computer is actually following. Today, we're going to pull back that curtain and take a look at this secret language.
Right, so you might just assume that your Python code runs exactly as you wrote it, one line after the other. But the truth is there's this middleman, a hidden language that's translating your commands. And honestly, understanding this language is the real key to unlocking better performance, debugging way smarter, and just getting a much deeper appreciation for how Python works.
So this secret language, it's called bytecode. The best way to think about it is like a universal translator. It sits between your very human, readable Python script and the machine itself. It's a super compact, really efficient set of instructions that can run on pretty much any system, which is a huge part of what makes Python so incredibly portable.
So how exactly does your code turn into bytecode? Well, it's this four-step pipeline you see here. It all starts with your .py file, right? Python first parses that into something called an abstract syntax tree, or AST, which is basically a structured map of your code. From there, that tree gets compiled into Python bytecode. And then finally, the CPython virtual machine, which is really the heart of Python, grabs that bytecode and gets to work executing it.
Okay, so how do we actually get a look at this secret language? Well, Python gives us our very own decoder ring. It's a module called dis. And yep, dis is short for disassembly, and it is our key to unlocking and actually reading the bytecode that our code spits out.
Let's start with something incredibly simple. A function we've all written 1,000 times, just adding two numbers. On the surface, it's just return A plus B. But what does our dis decoder ring tell us is really going on under the hood?
And there it is. That simple little addition function breaks down into just 4 bytecode instructions. First, you see load fast pushes our variables A and B into memory. Then binary add does the actual math. And finally, return value sends the result back out. This little sequence, this is what the Python interpreter is actually doing.
So we have the instructions, but where do they actually run? Well, welcome to the engine room of the Python virtual machine, and it's all powered by this beautifully simple but really powerful idea called the stack. The easiest way to think about a stack is like a pile of plates. You can only put a new plate on the top, and you can only take a plate from the top. It's what we call a last-in, first-out system, or LIFO. Let's actually see it in action.
Okay, let's just visualize this with a simple multiplication, like x times y. The very first instruction is load fast x, and as you can see, the value of x gets pushed onto our stack. It's the first plate in our pile.
Next up, the instruction load fast y runs, so it goes and grabs the value of y and just places it right on top of x in the stack. So now our stack has two things in it, with y sitting at the very top.
And here's where the magic happens. The binary multiply instruction comes along. It takes the top two values off the stack, first y, then x, it multiplies them together, and then it pushes the single final result back onto the stack. All that complexity is handled in just one elegant, super efficient operation.
All right, so we've got our decoder ring, and we've taken a peek at the engine. Now it's time to put all this new knowledge to the test and solve a performance puzzle that, honestly, trips up even really experienced developers.
So here's the puzzle. For adding just two numbers, what's faster? Simple A plus B or using sum AB? A quick look at the bytecode tells the entire story. On the left, A plus B is this direct, super efficient path. But look at the right. The sum function, even though it looks simple in our code, creates a much more complicated, winding road for the interpreter to follow.
So yeah, the verdict is pretty clear. For this super simple case, the sum version is way less efficient. But why? Well, it has to do a global lookup to even find the sum function. Then it has to build a whole new list in memory just to hold two numbers. And on top of that, it has to pay the overhead of a function call. Just remember, more bytecode instructions almost always means more work for the virtual machine.
This insight right here is really the key to writing truly professional, high-performance Python code. But it's not just about what you write. Turns out the compiler has some pretty clever tricks up its own sleeve. So let me show you a little magic trick from the Python compiler itself. Take a look at this function, return 2 times 3. Now, based on everything we've learned, you'd probably expect 3 instructions, load 2, load 3, and then multiply, right? Well,
What if I told you Python is actually smarter than that?
This is where the compiler shows off a little bit. It uses an optimization technique called constant folding. Before your code even runs, the compiler sees that expression 2 times 3, it calculates the result itself, and it replaces that entire operation with a single instruction, loadconst 6. It does the work just once, which saves the virtual machine from having to do it every single time the function gets called. Pretty smart, huh?
So, we've journeyed into Python's hidden world, and we've come back with this really powerful new perspective. What does this new superpower actually mean for you as a developer?
You now have the power to see what's really going on. You get that your Python script gets translated into bytecode. You know you have the magnifying glass, the DIS module to check it out. You've seen the stack-based engine that brings it all to life. And most importantly, you can now use all of this insight to write smarter, faster code. This kind of deep understanding, this is what separates good developers from truly great ones.
So my challenge to you is this. What piece of your own code are you going to investigate first? Find a complex function or maybe a really critical loop, run it through your new decoder ring, and see what secrets you can uncover. Happy disassembling!